Hi, I'm Nikki Mobtaker. Today we are going to be talking about a channelized 2 to 18 gigahertz receiver that we are demoing here. So here on this PCB, we have several interesting components. Here, the very small packages. The first one is a CSP1 limiter. And CSP versus QFN packages, CSP is definitely smaller, and you can see that here. The next component is an amplifier. So obviously we're using the limiter to protect the amplifier from high input powers. And then after that, that gets fed into an equalizer to equalize our spectrum, and then to our power divider. And so the equalizer and power divider are also CSP1 and CSP2 packages. Very small, very compact. So then the power divider feeds into two multiplexers. Those are the big packages you see right here. And here we have the VNA that shows the pass bands and the spectrum, but the GUI also shows it much better. So here for the demo, we have a carrier and a jammer, and we can change the power levels and everything. But what's also important, so this is the purpose of this demo is multiplexers, you're just trying to receive whatever signals you want to receive. So say you're scanning this whole band of frequencies from 0 to 18 gigahertz and you want to access one signal. With the switch filter bank, you can only access one signal. With the multiplexers, you can access any of them, just pick a port. So that's the purpose of this, and I feel like it's a very useful thing. So on top of that, we also are showing off our bullet housing filters, if you want to come on over. So I want to show the effect of the bullet housing versus our normal the normal multiplexer outputs. So channel 2, the pink, is has an additional bullet housing filter, and you can see the rejection changing from like 60 to 100 dB. It's steeper, but you see these ripples, these standing waves. We're working with connectorized now. There's a lot of distance. There are going to be standing waves. So what you can do is add an attenuator. We have one of our bullet housing attenuators right here, and then another filter. This is on an eval board, just to show that you can always buy an eval board and test it out. So I'm going to compare channel 2 to channel 7, where we have that additional attenuator attenuating the reflections. And you can see that the standing waves improved. Your insertion loss did not increase by much in your pass band, and you're obviously still getting that great rejection. This is the active doubler with switch filter bank demo. Right here, this is the block diagram of the demo itself. This whole block diagram is what's in this module right here. And so what it is an active doubler feeding into a switch filter bank. Now a switch filter bank, all that is a bank of filters, and you choose what pass band you want to let through, the signal you want to let through. So in this demo, we got two filters in our filter bank, and we're using the MSW20002CH to switch between the filters. So before that, we have an active doubler, the IMS2025CH. And then at the bottom here, we're comparing the additional filtering with just an active multiplier by itself. So this is the IMS2052. And so here on the GUI, we're comparing the performance of essentially an active doubler versus an active doubler with filtering. So down here, we have some markers comparing, but the spectrum really tells it all. So let me move it up a little bit. So again, demo and just the active doubler. You see that the 1F and 3Fs are suppressed. You don't even see them up here. But down here, the deltas are around 30 dB of additional suppression. And, you know, our multipliers do well with suppressing harmonics, but filtering will always help. And so to activate the second filter. We just have to get to that frequency, and we have it automatically switching. But here, 1F, totally gone. The delta, 42 dB. So that's the demo for this year. Thank you for hearing me.